Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Welcome to Lesson 21, Correspondence and Transformations. Classwork opening exercise. The figure to the right represents a rotation of triangle ABC around the vertex C. So here's the point we're rotating around right there. Name the triangle formed by the image of triangle ABC. Well, we rotated it, and if we're going to name it A became E, so that will be triangle E. B became F, so F, and then C is still C, so it's EFC, triangle EFC. All right, so now it says write the rotation in function notation and name the corresponding angles and sides. So this is a rotation. So you use the capital letter R for rotation. We're rotating around the point C, vertex C. So we're going to rotate around C, comma, 80 degrees. And what are we rotating? We're rotating triangle ABC. So a rotation centered at C, 80 degrees of triangle ABC would equal triangle EFC. Now it's asking to write the rotation in function notation, done, and name all corresponding angles and sides. Okay, so I created this little table here, and now we're going to fill it in. So corresponding angles, so let's start alphabetical order. Angle A corresponds to angle E. Angle B corresponds to angle F. And you can get this from the name too. A goes to E, B goes to F, C goes to C. Angle C corresponds to angle C. And then AB is the first two letters of this triangle, so I'd say side AB. AB corresponds to, so that's these two, corresponds to the first two here, so it's EF. Okay, and then if I go to BC, I'm underlining, or I'm drawing the line over B and C, then it'd be over the last two over here. So BC corresponds to FC. Okay, and then finally, if I name AC, I'm using the first and third letter to name that side. First and third letter from the name right here, AC. What's the first and third letter over here? EC. So AC corresponds to EC. And there they are. Okay, discussion. In the opening exercise, we explicitly showed a single rigid motion, which mapped every side and every angle of triangle ABC onto triangle EFC. Each corresponding pair of sides and each corresponding pair of angles was congruent. When each side and each angle on the pre-image maps onto its corresponding side or angle on the image, the two triangles are congruent. Conversely, if two triangles are congruent, then each side and angle on the pre-image is congruent to its corresponding side or angle on the image. And there's an abbreviation I use for that, and that is CPCTC. Corresponding parts of congruent triangles are congruent. CPCTC. Okay, page 2 brings us to an example, and it says, ABCD is a square, and AC is one diagonal of the square, so there it is. Triangle ABC is a reflection of triangle ADC, across segment AC. Complete the table below identifying the missing corresponding angles and sides. So here we go. Angle BAC is right there. If we're reflecting across AC, it is this segment right here. So let me just make this a little better, right there. There, that's not bad, okay? So if BAC is reflected across, if we folded this, it would end up over here. So if they're naming it BAC, then we want to name it DAC. Angle DAC. What in the world? Angle DAC. Then it says angle ABC. Well, let me erase these. Now angle ABC is this right angle. Reflect that across, and that's going to end up being angle D. We could just name it D, but they named it with 3 letters. So they said ABC, so we want to say ADC. And then finally, let's get rid of those. Angle BCA is right here. Reflected across, it would become angle BCA goes this way, so we want DCA when we name it. So angle DCA. Okay, so now we're talking about corresponding sides. So if we have side AB, which is here, reflected across is going to come over here. Picture folding the paper. That AB is going to become segment AD. Okay? And then BC, which is here, folded would end up DC. Okay? And then finally, AC. Well, AC is the line of reflection. We were told that. ABC's reflection of across segment AC. So if AC is the reflection, you fold it and it's still itself. So AC gets folded onto itself. A, are the corresponding sides and angles congruent? Okay, yes they are. Since a reflection is a rigid transformation, all angles and sides maintain their size. So the answer is yes. B says, is triangle ABC and triangle ADC congruent? Justify your response. And the answer is yes. Since triangle ADC is a reflection of triangle ABC, they must be congruent. Okay, page 3 brings us to an exercise. Exercises, remember, are supposed to be done on your own. So pause the video, see if you can do this, and then come back and check your answers. So it says each exercise below shows a sequence of rigid motions that map a pre-image onto a final image. Identify each rigid motion in the sequence, writing the composition using function notation. Trace the congruence of each set of corresponding sides and angles through all steps in the sequence, providing that the pre-image is congruent to the final image by showing that every side and every angle in the pre-image maps onto its corresponding side and angle in the image. Finally, make a statement about the congruence of pre-image and final image. Okay, so assuming you've done this, let's check it out. It says sequence of rigid motion, and then 2 in parentheses means that there are 2. So what happened from pre-image ABC to get it to image A prime? Actually, it's C prime, B prime, B double prime. So this was rotated about C, so that's a rotation. And then to get this over here, notice there's a vector. That means that is a translation. Okay, translation. Then it says composition and function notation. Okay, so you work backwards, remember? So what did we move originally? We moved triangle ABC. So I'm going to put that in parentheses. So triangle ABC is the last thing that we're talking about. What did we do to it? We rotated it, and it looks like 90 degrees. So let's just say it's 90 degrees. So we rotated it about the point C, or C prime. So we rotated it C, comma, 90 degrees. To get this from here to here. Actually, that's a negative 90 degrees, or 270. So I'm going to put a negative there. That is a clockwise rotation from here to here. To get A over to here was a clockwise rotation or counterclockwise rotation of 270 degrees. So I'm going to put rotation about C, negative 90 degrees. But then what did we do? Then it got translation of vector B prime B double prime. So to say that, we put T translation, and we do B prime B double prime with an arrow over top. So it's a translation of B prime B double prime after rotating it about C, negative 90 degrees, the triangle ABC. Then it says sequence of corresponding sides. Okay, so let's start with AB. AB corresponds to, AB is here, B prime, B double prime, B. Okay, they didn't really label this very well. So before I go any further, let's do this. To get this from here to here, notice I have a B here and a B prime here. A, well, this would be A prime, and this would be C and C prime, because it's a rotation about C. So AB became A prime B prime. And then it got translated. So now this is A double prime, this is B double prime, and this is C double prime. So AB ended up at A double prime, B double prime. Okay? And then they didn't give me a lot of room here, so I apologize. This is really hard to do. And then next side, let's do BC. So here is BC right here. This is BC. Rotate it, BC will become B prime C prime. So BC got rotated and became B prime C prime. And then it got translated over to B double prime, B double prime, C double prime. Okay, and then finally, the last side, let me get rid of this, is the side AC. Rotated, it's A prime C prime. Translate that, it's A double prime C double prime. So AC becomes A double prime C double prime, just like that. Okay, there we go. Sequence of corresponding angles. Let's change color because I'm running out of space here. So angle A became angle A prime, and then it slid over to A double prime. So A became A double prime, angle A double prime. Angle B became angle C became B double prime and C double prime respectively. So A became A double prime, B became B double prime, and angle C became angle C double prime. Triangle congruent statement. Triangle A, B, C is congruent to triangle A double prime, B double prime, C double prime. Okay, here's the next one, and there's a misprint in your student manual, or student edition, student version, whatever. There are 3 motions here. All right, so first thing I want you to focus on, let me do this. Let's focus on our vector. Okay, that's a transformation. Why am I focusing on this? Because look at the direction it's going. We're moving it from here over to here. So this is the direction we are doing all our transformations. So if we continue, so I don't want to start here and say this was a rotation to get to here, because this is a vector transformation of this B prime to B double prime. So notice this is B without primes, A, B, C prime, no primes. This has 1 prime, 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 double prime, double prime, double prime, triple prime, triple prime, triple prime. So notice this is triple prime, but it's shared. That is also a double prime from the translation of A prime over by this vector distance and direction. See? Okay. So with that said, there are 3 motions, and they're starting with our pre-image, which is over here, reflected across DE. So what did I just say? A reflection. And then after I reflected it, it was a translation. And then finally, to get from here to here, we have to rotate. Okay, rotation. So reflection, translation, rotation. Composition in function notation. Okay. So the last thing that was done was a rotation. So that's what I write first. It was a rotation. We rotated around A triple prime or A double prime, depending on what you want to call it. We rotated around A double prime because A triple prime does not exist until you rotate, so let's use double prime. Rotated around A double prime, and if I get my compass, not my compass, my protractor, put it right on A. Let me get my mouse here for this. Right there, and rotate it so that this is on the line AB, A prime, B prime. Okay. And then rotate this around to get to the prime, which is right there. Okay, so did you see that was 100 degrees right there? So when I click and hold that, it said, for some reason it said, there it is, 100 degrees. So that was a 100 degree rotation. Okay, but to get it from here to here, I had to rotate it clockwise 100 degrees. So a clockwise rotation 100 degrees is a counterclockwise rotation 360 minus 100 or 260 degrees. So I'm going to rotate this triangle about A prime, A double prime, 260 degrees. Okay, instead of saying 100 degrees, because the 100 degrees is negative. All right, so it's a rotation about A double prime, 260 degrees. All right, and then you put a parentheses. Then what was done? So we're working backwards. Well, then we did a translation of B prime, B double prime. And I put a vector on top of it like that. Okay, and then another parentheses. I don't want to write over my stuff, move that. Another parentheses, and then it was a reflection. What do we use for reflection? It's a lowercase r. Capital R is rotation, lower r, reflection. We reflected across segment DE. And what did we reflect across it? Triangle A, B, C. So there it is. Composition and function notation. Sequence of corresponding sides. Okay, so I've done this before up here. It's just going to go from the side without primes to the side with triple primes. So I'm just going to bring these in. Okay, hopefully you can see that. AB goes to A triple prime, B triple prime. BC goes to B triple prime, C triple prime, and AC corresponds to A triple prime, C triple prime. Sequence of corresponding angles is just simply angle names to angle names with triple primes. So angle A goes to A triple prime, angle B goes to B triple prime, and C goes to C triple prime. Probably better to put the angle symbol in front of all those, but they did not. Okay, so then triangle congruence statement. All right, so what triangle is congruent to what? What is the pre-image and what is the image? The pre-image is triangle ABC. Is congruent to triangle A, 1, 2, 3, B, 1, 2, 3, C, 1, 2, 3 primes. Okay, game over. Okay, page 4 brings us to our last example, our last exercise. And I've highlighted the pre-image. It was the red triangle ABC. That is our red triangle ABC. So let me move this. As you can see, this is the pre-image. This blue line segment I drew is our line of reflection. So if I reflect triangle ABC over it, it becomes this triangle here. Then I can take and focus on the next reflection line, which would be right here. Then this triangle would reflect over onto this triangle. And then finally, we're going to reflect one more time across this line, and this triangle will end up our image X, Y, Z. So it is a reflection once, twice, 3 times. So again, a misprint. This is not 2. Sequence of rigid motion, it is 3. And they are all reflections. Composition and function notation. Okay, so remember, we are working backwards. The last thing we reflected across was XZ. Reflection is lowercase r. So you'd say R, reflection, across, X, Z, segment. And then we reflected across. Well, if this is B and this is C, I would name this A prime. So this would be B prime, C prime on this triangle here, but we can use the names of the original if they're in the same vertex. So this point here is B, or B prime, or B double prime, or X, if you're following that. I'm going to call this segment here A prime B. So then we reflect across A prime B. And then we reflect it again, third reflection, and this time it's going to be across segment BC. I forgot my segment up here. So reflection XZ, reflection A prime B, reflection BC of triangle ABC. There's our composition in function notation. Sequence of corresponding sides. Okay. Here's AB. Let me change colors. So if I take side AB, I have side BC, and I have side AC. So I'll write those down first. Correspond to, correspond to, correspond to. AB becomes YX. BC becomes XZ. And AC is YZ. Okay. Corresponding angles I'll do over here because I'm running into this box. Angle A becomes angle Y. Angle B becomes angle X. And angle C becomes, C's out here, would come over here, angle Z. Triangle congruent statement. Okay. Triangle A. Let me try that again. I put A instead of the triangle symbol. Triangle A, B, C is congruent to triangle A, B, C, Y, X, Z. Okay, and that's that. Page 5 brings us to the end of lesson 21. Go to your problem set.